Hello everyone, this is Eddie the Magic Monk. Today we're going to talk about how to reflect a point using the line y equals x. So you can see here that on the Cartesian plane I have drawn a straight line y equals x. And when I talk about reflecting using this line, I mean that if I draw a point somewhere on the Cartesian plane, okay, so let's say for example point A is over here, I'm going to reflect it using this line so that it ends up somewhere over here. And if I give you the coordinates of A, let's say the coordinates is 1.7, 0.6, right? I want to know the transformation matrix that will give me the exact coordinates of A dash. So how do we do that? Well, the first thing we need to do is we need to construct the transformation matrix. So let the transformation matrix be M. Now to construct the transformation matrix, the first thing we do is we draw a point at 1, 0. So let's call this point A. And we need to think about what the image of A will be if I transform it using this transformation. So if I reflect 1, 0 using this line, what will happen to it? Well, let's draw a line from this point to our mediator, which is y equals x. Now, let's say this line is at right angles to a perpendicular line to the mediator. If we keep going and extend this line by the same length, so this line has the same length as this line, then we will travel to the same point on the other side, which is 0, 1. And this will be A dash. Now, another way of proving that A dash is going to be 0, 1 is to use the concept of congruent triangles. So you can see here that we have two shapes. They both have a right angle. Right, they both have the same side over here. Right, these two triangles, they have the same side over here and over there. So that's side, angle, side. And then these angles are also 45 degrees each because the line y equals x is directly down the diagonal. So therefore this point is 0, 1. Okay, so if the original point is 1, 0 and the image of the point after the transformation is 0, 1, I put 0, 1 down the first column of the transformation matrix. Okay, now how do we fill out the second column of the transformation matrix? Well, we are going to now name this point at 0, 1. We're going to call that our original point. And if this is our original point, then the image of this point using the transformation will be 1, 0, which is A dash. And we're going to put the result of that transformation on our second column, 1, 0. So therefore, this is the transformation matrix. Okay, now let's test it using GeoGebra to see if it works. So the question which we're going to do is reflect the point 4, -2 in the line y equals x. So all you have to do is use the reflection matrix that we've just discovered. So it's 0, 1, 1, 0. And we multiply it by the point 4, -2. And that will give us the image, which is x dash, y dash. Okay, so in case you forgotten the original equation for matrix transformations, it's the transformation matrix times the original point will give us the image. Okay, so M is our transformation matrix 0, 1, 1, 0. So multiplying M by the original point, and then let's write it all out. So we have 0 times 4 plus 1 times -2, and then we have 0 times 4 and 1 times -2, and then we have 1 times 4 plus 0 times -2, this equals x dash y dash. So then the answer is just -2 and 4 equals x dash y dash. And now let's show you guys the result on GeoGebra. So we have our original point is 4, -2, so let's plot that point. And we have the transformation, the image is -2, 4. And let's draw the line y equals x. And you can see here that the 2 points are equal distant from our line. Alright, so it's definite that they've been reflected. And if you want to know for sure, then what you can do is you can draw the interval. You can draw an interval between 2 points and draw a line between these 2 points, draw a point at the intersection, and draw a point somewhere down the diagonal. And then if you create an angle between these 3 points, and you can see that they're right angles, so it's 90 degrees over here. And then if you draw another two lines, so let's say we draw from B to C, and you can see the length of that line is 4.24. And then if you draw another line from A to C, and the length of the line is exact same thing. Okay, thanks for watching guys, see you next time.